I'm with Practical Farmers of Iowa. It's a farmer member organization. We also allow Minnesota farmers to join if you'd like to partake in our organization. So I'm going to talk about cover crops, and many of you maybe have heard about cover crops because they're good for water quality and they help reduce soil erosion, and that's all great, but also cover crops could potentially help us grow better corn and soybeans. And so I'm going to talk about some of the PFI research from trials that we've been doing over the last 10 or so years on this topic. So this is really all too common in Iowa, and maybe when you get across the border, it stops in Minnesota. Does this kind of erosion events, do we not see this in Minnesota? No, we see this in Minnesota, right? Okay. So we derive much of our lifestyle and our income off of soil, and so to me this seems unacceptable if we're going to try to stay in business long term. So we really need to take care of this kind of erosion issues that we have. And so today I'm going to talk about why is the Corn Belt leaky, why do we see systems like what I just showed, what does Practical Farmers do, what are things that we work on, how do we help farmers make changes, and then what are some of our research results. So I am a generation off the farm from Northern Illinois. I come from an area that looks much like this in the spring, and when I drive home from Des Moines, which is where I live now, this kind of looks normal. And over the last 8 years, I'd say I see more green cover crop fields in the spring on our neighbors' farms, which is good, but there's definitely not enough. We need 60% deployment on corn and soybean acres to really make a dent in tackling erosion issues and water quality. And then I went to Iowa State and got my master's and partnered a bunch with Megan actually on some of her research to just learn more about how to make cover crops work in a corn soybean system. And so today now I work at Practical Farmers. So I put this provocative statement up there, why is the Corn Belt leaky? Because I think it's important for us to understand why we're maybe in this soil erosion issue, why we're at this issue today. Why do we have this situation? So nitrogen and soil can't really escape the field when we're growing corn and soybeans, which is during the growing season. So we don't have much loss of nutrients or much loss of anything when corn and soybeans are actively growing because they're protecting the soil. They're sucking up nitrogen from the soil and putting it into proteins, into beans, and into corn. And so things can't really escape. But then in the winter time, we don't grow anything, or we don't grow much, especially in Iowa. We don't grow many winter plants anymore. And so that's when our soil is the most vulnerable. And that's when we have big soil erosion events, and that's when we have big loss of nitrogen, and when we even have big losses of dissolved phosphorus. And so this is not a normal system. This isn't what nature would do, right? Nature would put weeds out there. Mother Nature would have some sort of plant growing in the wintertime. And this wasn't normal for Midwestern farmers really until about the 70s, I'd say. So this is the percentage of Iowa planted to different crops over the last 100 years. So time is at the bottom, and percentage of the land planted to different crops is on the y-axis. And so if you can't read the legend, what crop do you think is yellow? Corn. So 60% of Iowa's landscape has been corn, planted to corn for about the last 100 years. What do you think this light blue is up here for Iowa? Oats. So previous to this time period change in the 60s and 70s, we used to grow small grains and legumes. Those were often underseeded with red clover or alfalfa opposite corn. And so if we're all able to answer this question, when do small grains and legumes grow? When do they normally grow on the landscape? In the spring, in the winter time. They're cool season plants. They're cool season grasses and legumes. And when does corn grow? In the summertime. It's a warm season grass. So previous to the 60s and 70s, we had about 60% of our landscape in a warm season grass and 40% in a cool season grass. So we had roots growing year-round more often. Now, what do we think this green crop is now that we grow opposite corn? Soybeans. And when do soybeans grow? In the summer. So now in Iowa, on 23 million acres, we have two warm season plants growing for 6 months out of the year. And for 6 months out of the year, we don't grow much. And so fundamentally, that's why we have a water quality problem, that's why we have a soil erosion problem. And over time, that's going to affect corn and soybean yield. So if we want to do a better job at protecting future yield, we need to stick some winter plants into this warm season system. And so to stick winter plants into this warm season system, we can use winter cover crops like rye or wheat or barley or oats. We could go to 3-crop rotation. We could plant hay again. Now, this is not unique to Iowa. Here's Iowa up here. Here's Illinois. Illinois had more winter wheat always compared to Iowa, but they had oats. Then we see this massive shift in the landscape. Indiana, same story, and even in Minnesota. So fundamentally, we're not putting water from the soil into the air in the wintertime anymore like we used to. And so that water, the way we manage water now is just for about 6 months out of the year. And when water is allowed to move whenever it wants to without having a plant to intercept it, it'll take nitrogen with it and it'll take soil with it. So the wintertime, we really need to cover it up. It's too vulnerable. And so winter cover crops are a way to do that in a corn-soybean rotation without maybe going to diverse rotation like adding alfalfa because maybe we don't have livestock anymore. How many in the audience have been trying winter cover crops in a corn-soybean rotation? Couple. How many are really going to be interested in it after this talk and going to go home and do it? Yes. Okay, so we started this cute campaign, 8 years ago. Don't farm naked. Plant cover crops. Cover up that soil. It's too vulnerable, it's too precious, and it shouldn't be allowed to be naked all winter long. And no-till is not enough. No-till is not going to cut it. We don't have an active photosynthesizing plant out there when we're doing no-till, right? We just have brown residue, which is good for some protection, but we really need a green growing plant, a winter green growing plant to really improve the soil over time. Okay, so what is a cover crop? It's just a plant that covers the soil between other cash crops. So in a corn-soybean rotation, it would predominantly be a winter plant in between that summer system. So this is a flown-on cereal rye cover crop into standing corn stalks in the August-September window of 2012. This is in Cherokee County. And the farmer caught a rain in the drought time of 2012 and then harvested corn within 4 weeks because it was bad because of the drought. And then he brought cattle in and made actually a decent amount of extra cash off of this ground because of the cows consuming the corn stalks and that nice green material. Farmers have observed that actually cows will eat more corn stalks when they have green material in there as well because it's more balanced diet for them. Turning over corn stalks is good for corn yield long term, right? It's a lot for soil microbes to break all this carbon down, but a ruminant really breaks it down quickly. So we can add income to these kinds of systems by putting green there and then bringing cows onto it. Okay, so how does Practical Farmers work? So we're a farmer member organization. We have about 3,000 members. I work on cover crops because our membership demands it, and so I had to learn about what they are about 10 years ago. And so we help farmers do research, and then we help farmers talk to each other about those results so that we can demystify new things like cover crops or growing oats again or whatever it is. And so at the end of the day, our goal is to save farmers time and money to avoid mistakes on making systems better. So one of the ways that we do this is through on-farm research. This is a typical randomized replicated on-farm research design that farmers would do in our organization. Have any of you folks conducted trials like this on your farm? With anything, with other products even? Okay, well this is the best way you can know if there is an actual difference in something that you try. And so maybe before you're ready to put cover crops on 200 acres, although I might convince you to do that, before you're ready to do that, you might try some strips and skips. So in the fall on this trial, farmers are planting rye in strips with skips, and then in the spring they kill it, and then they plant corn or soybeans, depending on the rotation, and then in the fall they'll give me yields off of each individual rye strip, and then I run statistical analysis on it. So then we can see, does rye affect corn or soybeans negatively? And I'll show some results of that trial here as we go through. So this is all part of our cooperators program, and every year we run a number of trials, and a bulk of those are focused on cover crops, and then we help farmers go out and talk about the research from those trials. I've brought 1 or 2 handouts in the back there that you could take at lunch about those results. And so these are where our trials were located in 2016. We had 76 trials, and 25 of them were focused on cover crops. So we kind of do a lot of cover crop research. We will take Minnesota farmers. You also can participate in research with us. Okay, and then we host field days. We help farmers then get out to the field and talk to other farmers. How many of you have attended a cover crop field day on a farm? Not just a university thing, but like with a farmer. That's great. That is really the place to go get the information, because farmers are going to tell you straight how you're going to make these systems work. So this field day was held at Ward's farm. This is Ward right here, a good backside picture of him. And he had spread rye on different fields the fall before. This is this spring, actually. And on one field where the fertilizer spreader had a certain type of fan spreading it, which I'm going to get wrong, the fertilizer spread farther than the rye spread because they're different weights. And so then he had strips of rye and no rye, which is not what he wanted. He wanted a field that looked uniform like this, because he wanted to use that rye as his first line of weed defense in the spring. And so when he realized the fertilizer application with rye was not ideal for controlling weeds, he could tell all of his neighbors about that. And he was really embarrassed, and he didn't really want to tell anybody, but he saved a lot of other farmers time and money to avoid that in the future. So field days are really good ways to really get down to the nitty-gritty on that. And then we help farmers do on-farm research. This is a picture of a farmer down in Oskaloosa, and he's in our tea bag study, and that study is to evaluate how fast tea that's in these little nylon pyramids, green tea versus red tea, how fast those will break down in different kinds of cover crop fields. So if red tea, which is high carbon to nitrogen ratio, breaks down as quickly or close to as quickly as green tea, which is low carbon to nitrogen ratio, we would assume that soil is very biologically alive. And so people want to do the soil Haney test and do a lot of soil health scores, and those are great, but they're kind of expensive, and pallets of tea bags are not very expensive. So we're calibrating this new test across 15 locations with a researcher at Iowa State, and Michael, this is the farmer here, he's in one of those studies. We'll have that published here, I think, in actually a month or so. Okay, and so by saving farmers time and money, then I get pictures texted to me that look like this, where this farmer, Megan, you might actually even work with Steve Plate, I'm not sure. You know, he's really happy about what his cover crop looks like, and you know, just all that growth that he had last spring. Okay, we reached about 10,000 farmers last year across 75 events. And then these are the changes that farmers have said they've made by participating in Practical Farmers of Iowa programming, doing on-farm research, attending events. And of our membership, which are corn and soybean farmers only in the membership are about 1,300, 73% of our corn soybean farmers use cover crops or have added it in the last 3 years, which I'd argue no other organization can probably make that claim. We have a really high usage, high rate of farmers using cover crops. So if you're getting interested in it, you should join PFI and get into the network and learn from others who are doing it. Okay, now for some of the research. So we wanted to see of farmers who have just started using cover crops, maybe 4 years and under across the entire Corn Belt, what would be the changes in their returns on fields that were planted to either corn or soybeans in 2015, and fields that in pairs, one had had cover crops on it and one had not. And so we had farmers respond to this survey, and we had about 200 responses that we could actually use to do analysis. We're partnering with Iowa State on this study. So I'm just going to kind of go through this. So changes in revenues when cover crops were terminated with herbicides, and then we planted corn for grain following it across the Corn Belt. This is this slide, and the next slide will be soybeans. Our changes in revenue were things like increases in corn yield or increases in payments from cost share. Those would be the two main sources of revenue. And so on average, farmers increased revenue $16 on cover crop fields compared to non-cover crop fields in 2015 that were planted to corn. Changes in costs down here were $36.91, and those cost increases could have been an extra spray for armyworms. Have we had armyworm issues on rye up here? Not so much. Okay, that is probably a southeastern Iowa thing. So maybe there's an extra spray involved. Maybe our nitrogen program, we put too much on or put the wrong program on, so we had increased costs there. Those would be the main costs. Oh, and then planting the cover crop was a cost, and purchasing the cover crop seed. Those were the main costs in this changes in cost column. And so the net change in profit is negative $20 per acre. So we have a loss. We have a big loss per acre when we have cover crops killed with herbicides going to corn on farmers new to cover crops. And when we didn't have cost share, we had a really big loss. So I don't put this out there to scare you. I put this out there for us to talk about this. Even the best farmers over here, the ones who were able to almost break even, were still at a negative $5 per acre when cover crops went to corn. And the big reasons why were, one, these changes in revenue were actually a lot of yield decreases on corn following cover crop. And the cover crop in this system was mostly rye. Can anybody speculate why we would have corn yield loss after a cereal rye cover crop? Because of grass following a grass. That is the number one reason, right? So our nitrogen programs that we have today, like if we're doing a 4R program or nutrient stewardship program or what the co-op is selling us, is probably the wrong recommendation for rye to corn. So farmers early on using cover crops, and if you've been trying rye before corn, you've even seen this. You can have a 10 or more bushel loss of corn following rye. And it's usually due to the wrong nitrogen program. And then changes in costs, another place where we are probably spending too much is we're maybe trying to use really fancy cover crop seeds that are more expensive. And we might be applying things with planes as we get started, and that's more expensive than drilling or broadcasting. So there's things in here that I'm going to talk through in my presentation about ways we can control our cost better and hopefully avoid yield losses, which is why we get the negative on corn following cover crops. So this is probably one of the big reasons why we don't see mass adoption of cover crops. Okay, but on the soybean side, it's really a different story. And so this is probably the least risk, actually I'll just say this is the least risk system, and farmers should massively deploy cover crops to soybeans because they're such low risk. So changes in revenue, this is on cover crops terminated with herbicides followed by soybeans. And so changes in revenue, we were $60 ahead, and those were because of cost share and because of yield increases of soybeans following cover crops. And then changes in costs, similar costs, and again that would be the cost of the cover crop, the cost to plant it, any changes in our herbicide program that we might have had. Those are the main three. And so then our net change in profit is 25 is positive, and if we take out cost share, we're basically break even at negative $3. And for the best farmers over here who are able to reap very higher yields for sure and control their costs better, they're at $30 per acre break, they're $30 positive without cost share. So if you are thinking about getting started with cover crops, cereal rye planted on corn stalks, post-harvest for example, going to soybeans is the least risk system, and there's the highest potential to at least break even as you're getting started. And then over time, learn how to maybe profit from those cover crops. Okay, so to make cover crops pay, we need to control costs first. And so the best way that we can get started with that is picking the right cover crop species. So many of you maybe have seen a picture like this before with these ginormous radishes. Have you seen these before? Have any of you planted and gotten radishes that big on your farm? When did you plant those radishes?
It was sweet corn.
It was sweet corn, so it was early. Yeah. So I'd say back in 2010 to 2013, we heard a lot from cover crop seed companies that these were the next best thing since sliced bread, and we should all plant them, and they're like $3 a pound, and we should plant 3 to 5 pounds per acre, which is pretty expensive. And then we got these size radishes when we flew them on into corn and soybeans. This is from central Iowa. And so, you know, a lot of farmers might have been cranky because it's just not a solid radish like what we had expected. So it's not that radishes are bad. That's not what I'm saying. I'm just saying we need to make sure that we know when to plant them to maximize their growth, which is usually planting them early in August, post small grain harvest, or on early corn silage or sweet corn fields, for example. Flying them on into corn and soybeans is not awful, but you're just not going to get a lot of growth. Their prices come down now, which maybe makes them more of interest to farmers to mix in a pound or so. But I wouldn't get carried away with radishes. So when we noticed that farmers were planting a lot of radishes because of what seed companies were telling them, we started evaluating all cover crop species. And so we've been conducting for the last 5 years across 10 to 16 locations annually cover crop variety trials in Iowa. And we evaluated species in the grass group, in the brassica group, and in the legume group. In total, we've evaluated 49 cover crop species. So things in the grass group would be like cereal rye, winter wheat, winter triticale, winter barley, spring wheat, oats, annual ryegrass, Canada wild rye. We put some prairie species in there. And then species in the brassica group would be like rapeseed, turnips, mustards, camelina, field pennycress, radishes. I think I said them all. And then legumes would be things like hairy vetch, red clover, crimson clover, peas, partridge pea. Okay, so we evaluated a lot of species over a lot of years. So I don't expect you to be able to read this slide. I just show this. This is the evaluation of what the fall growth was of all those different entries, and all of their fall growth opposite rye. So rye in my mind over time we've realized is really our control species. It's our check for growth. So rye is at the top, and then these cascade. These are mostly the winter small grains here: barley, wheat, winter barley, triticale, and then as we go down further we get into more of the brassicas. Their fall growth is pretty good, and then further down here are the legumes. So like here's lentil, for example. So its fall growth is not stellar. Hairy vetch by itself, there's radish right there. I'll just show you one more, and there's oats right there. Oats has really good fall growth. Oats and barley have really good fall growth. Okay, and then in the spring, we also took the biomass in the spring to evaluate it. Again, here's rye over here, and so there's less spring growth on most cover crops because quite a few of them winter kill. These again would be the winter small grains, and some of them do okay overwintering, but some of them winter kill. And then we get down into hairy vetch, we get down into alfalfa, common vetch, rapeseed, lentil, turnips, some of the things that for sure winter kill. Okay, so all that said, basically this is the key takeaway. If you can plant early, like by September 10th, which would be after small grain harvest or sweet corn or early corn silage, you can plant from any of these groups and have a fantastic fall and even spring growth. So you can mix it up and get really crazy and plant 12-way mixes. But if you're planting, if you have corn and soybeans in the way and you're gonna fly it on, you really can only plant stuff from the grass and brassica group. So that would be things like winter wheat and turnips, or rapeseed and rye, things like that. And then if you're gonna plant post-harvest, then the grass group is really your only choice, and really it's only winter rye in the grass group. So up here, I'd say in maybe 2 or 3 county tiers north of us, I bet you could plant winter rye until Christmas as long as the ground's not frozen and have no problem. You won't have much fall growth, but if you're gonna go to soybeans, you'll have it there in the spring. So we have a long window to really get rye in. And so we just need to be careful when we want to spend money on the other fancier cover crops because they're more expensive, and we need to plant them at the right time or we might waste our money. So if you're unsure about all of that, we made this handout. I don't know if Matt could help me hand this out. This is this decision tool thing that me and Megan was involved in this, and some other agronomists were involved in this. If you want to take one, you can take that home because it's kind of hard to read it on the screen. So this handout is basically a set of questions with yes/no answers to guide you through maybe the cover crop you want to land on. I think cereal rye is the answer to everything, but there are other cover crops out there, and for your goal, it might be another cover crop. It might not be cereal rye. So this decision tool helps you go through things like, are you planting before September 15th? Yes or no? Okay, yes, I'm planting before September 15th. Okay, are you overseeding that cover crop? Yes or no? Okay, no. Then that means I'm drilling a cover crop, probably post oat harvest. And then if you turned over the sheet of paper, it would take you to the first column of recommendations, which would be right here. And so this is just sort of a guide to get you thinking. If you haven't started using cover crops yet, things you might want to think about for next fall when you try them for the first time. Another key thing on this handout that I think is really important, we ask, are you following corn grain? Will your following crop be corn grain, yes or no? Okay, so if my following crop is corn grain, yes, can I apply 30 pounds of nitrogen at planting? Like either in a 2x2 or as the carrier for your herbicide, or really, really early side dress. So can you move nitrogen from another time, like fall anhydrous or spring anhydrous or side dress, move it to the planting window, 30 to 35 pounds? If you can do that, then you could get away with an overwintering small grain because that would protect yield. But if you can't put nitrogen on a planting, then you should go with a winter kill cover crop. And I say this because rye or wheat or triticale, any grass that's going to overwinter is sucking up nitrogen, which is good for water quality. It's holding it. And then corn, planted right after that, can't get access to any nitrogen. So you need to help it out by putting on 30 to 40 pounds at planting. So that's one good takeaway that we had from this handout, and I think that's probably it. Matt, could you hand out, I'm sorry, you just sat down. Could you hand out this one too? This then is more in-depth recommendations on rye, on corn following rye specifically that you can take home with you. Another thing on that handout that I'll just bring your attention to is to focus on getting planted as early as possible. So on the back side, you'll see cover crops and heat units in this bottom box. So in central Iowa, our heat units after August 1st could be on average 1,300. A month later, they're cut in half, and a month after that, they're cut by a third. So by October 1st, our heat units going into winter, at least under 300, which means we don't have many cover crops to choose from. Winter grains like wheat, rye, and barley wheat, rye, and triticale are our only choices. And we really need to prioritize getting things planted as early as possible. So like this fall, things were late, and it's okay to plant later, but the sooner we can get it in, the more time we're going to take advantage of these heat units. And so these heat units are based off of central Iowa. So here, subtract like 500, and that's probably where it is, which would be negative after October. So these are just good guidelines to think about. Try to get planted as soon as possible. Pick the right species. This will help us save on our costs when we're doing cover crops. Okay, another study we did was to evaluate how good are mixes. So there's a lot of interest in planting mixes, and I think that's cool, but I worry that maybe we're spending too much money. So we wanted to evaluate mixes of cover crops, so either oat versus oat in a mix with radish and hairy vetch, or rye in a mix, rye versus itself versus rye in a mix with rapeseed and radish, I think was what the mix was. So we evaluated mixes versus sole species, and then we evaluated high boy overseeding. So that's the high boy, this is what it looks like, around the Labor Day window, versus drilling post-harvest. And so we have a planting date study on top of a mixes versus sole species study. So this is fall biomass. This is 2014 and this is 2015 in the fall. And this is what the different biomass of the different treatments looked like. So where we had the high boy, you'll notice we always had better growth on cover crops where we planted early. And so we'd expect that because we're planting, you know, in Labor Day versus the drill, which would be in October for sure. So planting date's really important. And then let's just look at the mixes. So here we see in the fall, this mix versus oats by itself. Yes, the mix was a little bit better in growth. This is, I don't know, 280 pounds dry biomass versus almost 300. And just to calibrate your eye, 200 pounds of dry biomass is like this amount of cover crop. It's just not very much. So that's not that big of a difference there, I'd say, to warrant the extra cost in the mixed species. Then in the fall of 2015, where we had the rye part of the rotation, we see rye outperforms the mix for sure. And rye biomass in the fall was about 400 pounds of dry biomass compared to if we're planted late with the drill. Okay, then the rye mix is the only thing in this study that's going to overwinter. So then this is in the spring. And we have the high boy, obviously still better growth than the drill because we got more fall growth started in the spring because we had an earlier planting date. So planting date's really important. And then we see rye by itself really outperforms the mix in both planting dates. Let's see, this is up to 7,000 pounds of rye. So 7,000 pounds of dry biomass rye is probably waist height is 7,000 pounds of rye. And this is down here, this one's 3,000 pounds of the mix. And that's about, well, no, 7,000 pounds is probably above your waist. 3,000 is like right here, kind of at your hip, I'd say. Okay, so anyways, that's a lot of growth. So in my opinion, after looking at this and hearing farmer, observations, if we could plant early, the mixes make sense. If we get planted in August in an open field post-harvest, mixes probably make sense. We can get more growth. But if we can't plant early and we're in this window, sole species is probably the way to control costs. Okay. Second point is to making cover crops pay, we need to make sure we protect and, if we can, increase yield of corn and soybeans, obviously. Okay, so from the study that I showed you the picture of earlier, we've had these plots in place for 9 years across 6 locations in Iowa. And so again, every fall the farmers plant rye, in the spring they kill the rye, and they either plant corn or soybeans across the whole plot, and then they give me yields on each individual strip. Okay, so here's the yield results. So in the early part of the study, this is corn yields in the 2009 and 2010 year, and these are corn yields in the 2011 through 2016 year. In the early part of the study, 3 out of 10 site years had a yield decrease on corn that was significant following cereal rye, and 7 locations had no yield differences where they followed rye and didn't follow rye. These 3 locations that had a yield decrease, one was a significant yield loss of 30 bushels, and it was due to glufosinate, which is Liberty, failing to kill the cover crop after 3 applications. So there was rye headed out in a cornfield. So growing rye and corn together is not a good idea. Growing rye for seed and corn together is not a good idea. So most farmers, I'd say, and Megan, you can maybe confirm this, use Roundup to kill cereal rye for sure. It's very consistent and it always works. So even at cold temperatures, I've been surprised farmers have told me they're applying rye sometimes at 35 degrees air temperature and getting a good kill with Roundup. Okay, the other 2 locations that had a yield decrease, they had the wrong nitrogen program. So they had on the right amount of nitrogen, but they had all fall anhydrous down going to corn. And so when you have all of your nitrogen down as anhydrous in the fall and nothing on the planter, the corn struggles in the month of May to get access to nitrogen because the rye is holding on to it. The winter small grain is holding on to it. So once farmers realized those things, and we all learned that together, I didn't even know that 10 years ago when we started this. We changed nitrogen programs. All farmers changed them to these programs where it's maybe 75% of nitrogen's put down in the fall or in the spring as anhydrous, and then they have, the rest of it put down at planting. Then we've had no yield decreases since then, And we also learned how to really control rye well with glyphosate. And then what's great is last year we had 2 sites have significantly higher corn yields following rye than no rye. This was the yields of 2016. So this follows our hypothesis that it takes probably 8 to 10 years to see an improvement in the soil when we're constantly cover cropping in a corn-soybean rotation. And so I believe now we're seeing those results of that improvement in soil where we're getting higher corn yields. And this was about a 5 bushel increase in corn yield. But it took us 8 years in a corn-soybean rotation to get there. So we'll have a publication from this coming out soon with the 2017 yields, and we'll be able to see if that corn yield increase, if we keep seeing that or not. Okay, so on the soybean side of that study, where farms were in soybeans every other year, right away in the early part of the study, 2 out of 6 years had a soybean yield increase, and it was a 4 bushel average increase on soybeans that followed rye. And 4 out of 6 years, there was no difference in soybean yields. And then later part in the study, 13 out of 19 times, no difference in soybean yield. 1 year we did have a soybean yield loss compared to no cover crop. And then 5 out of 19 times we had soybean yield increase, and these were higher increases. They were 6 to 8 bushel average increase in soybean yield following cover crops. All these farmers were new to cover crops when they started the study, so I'd say they're pretty typical of many Corn Belt farmers adding cover crops, so results on your farm would probably be similar. But you could avoid the mistake of the wrong nitrogen program, and you could avoid maybe using the wrong herbicide program because we've learned sort of what works better. Okay, another study that we have been conducting, that farmers have been doing, is how far can I push the envelope? How long can I let the rye grow and then kill it before I plant soybeans? This is a site down in central Iowa. We've had 3 farmers conduct this kind of study over 2 years. So Jeremy had a field of rye, and then he killed rye in strips. Let's see, these dates, this was killed, I think 2 weeks before this was killed, and then he planted soybeans across the whole thing. So he essentially planted soybeans into dead rye versus green rye, and he wanted to see what that effect would be on soybean yield. But what he noticed was come August, he still had really good weed control in those soybeans. And so you can see that mat of the cover crop laying there in between the soybeans. Have other people seen this, where you're using rye?
Did you roll that down, or did you just kill it?
He didn't roll it down, he just killed it. We do have a study that we'll publish here soon where farmers sprayed rye with Roundup and then either rolled with a land roller or didn't roll, because we notice rye stands up still. After you spray it with glyphosate, it still stands, and we can get pigweed coming through that or other weeds. So if we can roll it, we can get a better mulch. In this case, he did not roll it. Okay, so he had really good weed control, so he decided to change his weed management strategy on the late terminated strips versus the early terminated strips. Okay, so as far as yields go, in 2016 and 2015, there was no statistical difference in the soybean yields. The soybeans following the early terminated strips are in brown, and the soybean yields following the late terminated strips are in green. So there's no difference in bean yield. Jack Boyer in 2015 was able to save $10 per acre on his herbicide costs in the late terminated strips versus the early. So that's about covering half of the cost or so, a little bit under half of the cost of planting the cover crop. And then Jeremy was able to save $50 per acre on his herbicide expenses and his weed control in the late terminated strips. And so that more than takes care of the cost of doing the cover crop. We did not see any differences though in weed control costs in these 2 site years. So maybe sometimes we can reduce herbicides, but maybe not all the time, to control weeds. Okay, one other thing that Jack measured when he was doing this trial was just what's the soil temperature differences between rye terminated early and rye terminated late in this study. This was in 2016. And then what's the water content of the soil in the early rye versus the late rye. So this is on May 8th versus July 15th, the soil temperature differences in the early rye, which was terminated on April 24th, versus the late rye, which was May 8th. And so on May 8th, soil temperatures were 2 degrees different they were 2 degrees colder in the late terminated strips. And then come July, both strips were at 69 degrees. So what's interesting about soil temperature being 69 degrees on July 15th? It's pretty cold, right? What would soil temperature be if there was no cover crop there on July 15th in central Iowa? Like 80 to 100 degrees. So it would be much hotter. So even the early terminated rye was able to reduce the soil temperature. And so why is that good? That's good because soil biological life really is unhappy above 100 degrees. And so that can affect plant growth. It can affect root growth. It can affect a lot of stuff. And so keeping the soil temperature cooler in the summer is really good for corn and soybeans. Okay, so now what about water content? So on May 8th, when he checked water content in the early strips, we were at 31% and the late strips were at 22%. And so this is what we'd expect when rye is big. It pumps a lot of moisture from the soil into the air. The shorter it is, the less moisture it's evapotranspirating than when it's bigger. And so come May 8th for Jack, those late terminated strips, for him, the field was more fit because it was 9 points drier than the early terminated strips. So potentially, this field could be planted when other fields without cover crops could not be planted because they'd be too wet. Then between May and June, this is a really critical window that we need to be careful on, and we can't predict what's going to happen, but if we're dry at the end of May into June and we killed rye when it was pretty big, we could be moisture short. In 2016, we had enough recharge, In 2016, we had enough recharge rains between May, which was the termination date, and the July 15th date when he took the moisture samples again, that the system had recharged itself. So the early terminated was at 36 and the late terminated was at 35% moisture content. This year, though, because of a dry June, we would have been much drier in these late terminated strips to the point where we could have affected growth of corn and soybeans. So there's really no way to predict that in early May. I guess I would have always thought we have wet Mays and into early June, and then, we don't. So we do need to be cautious pushing the envelope with rye and letting it get too big because it will suck a lot of moisture out of the soil and potentially decrease water availability to the corn and soybean plants. We need to be careful and really see what have we had for spring moisture? Where are we at going into that June window where we may or may not get a lot of rain? Okay, so 2 other studies that I'll go over, and then I'll open it up to questions. So Dick Salone wanted to try the same study that Jeremy tried, but with corn, and he really wanted to push the envelope and plant corn green into rye, which this is an advanced system. Has anybody done this, planted corn green into rye? Well, you kind of did because you planted corn green into oats. I would say don't do this right out of the gate. Wait until you've played around with cover crops a couple of years before you try this. So Dick killed cover crop here on April 17th, and then he killed this and waited till May 3rd, and then he planted corn into these strips on May 5th. And he tracked soil temperature across that time period. So he killed rye in the early strips here on this mid-April date. Then this is the late terminated strips. This is when he planted corn. This is the soil temperature. The brown strip is in the early terminated cover crop, and the green is in the late terminated cover crop. And so the only time we really see a big difference is right here around May 20th. The smaller cover crop was warmer than the heavier cover crop, but not much. And that's good. That's useful information because I hear farmers all the time say cover crops is going to make my soil much colder. And what some new science is saying is that because those roots are the plants are photosynthesizing, and there's sugars, going into the plant, which then would come out to the root, there's microbes living and dying and creating energy below the soil surface. And so that helps protect some of that coldness that we think is going on. And then second, When a field is bare and it doesn't have any residue on it, it might heat up really fast in the morning and have a high peak, but then it drops in the nighttime and it acts more like a desert because there's no insulation. So really warm in the middle of the day and then really cold at night. Where with insulation from the cover crop, we might be able to accumulate heat better and hold on to it. That's some of the thinking around why a cover crop might not be much colder than a bare field. Okay, so then Dick really honed in on his nitrogen program. And so this informed a lot of the recommendation that's in the handout that I had Matt hand out. So Dick's go-to system is this 35 pounds of N-on right at planting as a 32% in a 2x2 plus sulfur, and then he puts on the bulk of his nitrogen at side dress. And so he planted into heavier rye versus lighter rye with the same nitrogen program. And statistically speaking, he had lower yields in the late terminated rye, which is the green bars, versus the early terminated rye, which are the brown bars, and it was a 5 bushel difference. So he did lose 5 bushels by planting green. But for Dick, that wasn't that big of a deal because he was really happy that he could let the rye grow that long and plant corn into it and not take a severe yield hit. So that informed another study that he did this year with us. Okay, now this is a very complicated study. So one study led to 2 other studies and they're very complicated. Okay, so let me just go through these. So he did again early versus late terminated rye ahead of corn, and then he varied nitrogen, and he also varied previous crop. So when the previous crop was corn, he had a low nitrogen treatment in the early versus late terminated rye, and he had a high nitrogen treatment in the early versus late terminated rye. And his nitrogen program for the corn on corn strips were 76 pounds of fall manure, 35 pounds of nitrogen at planting, which is in that 2x2, his standard, and then he varied side dress. He put on 20 extra pounds of side dress as his high nitrogen treatment. So his total N for the rye in a corn on corn system was 181 versus 201, okay? And then where previous crop was soybeans, he had again low nitrogen versus high, and the low system was 15 pounds of N-on before planting, which was as MAP, 35 pounds of N-on at planting, and then he varied side dress again, 100 pounds of N-on at side dress and 120 pounds of N-on at side dress as the high rate, so 150 versus 170. Rye was terminated either 21 days before corn planting, which would be a typical recommendation, usually 2 weeks is what we hear from the university, versus 3 days before corn planting, and corn was planted on May 8th, and this is in northeast Iowa, just the county north of your county, Steve, which is, what's the county north of Benton County? Buchanan, he's in Buchanan County. Okay, so now let's look at the yield. So of the corn on corn system, this is, let me just go through this. This is early terminated with low nitrogen and high nitrogen, and then late terminated with low nitrogen and high nitrogen. Okay? And so the letters at the top indicate statistical difference. So the early terminated rye with a high rate of nitrogen was statistically similar to the late terminated rye, which was terminated 3 days before corn planting with the high rate of nitrogen. Numerically, they were 5 bushels different, but they were statistically the same, hence the letters. The early terminated rye with the low rate of nitrogen was statistically the same, but numerically lower at 230, and then the late terminated rye with a lower total rate of nitrogen was statistically lower at 222. So from this, rye in this system, actually cover crop in this system, only achieved about 2,500 pounds of biomass, max. That was the height of the late terminated rye. So as we were trying to figure out in the office how to better explain this, we think maybe up to a certain amount of biomass in the spring, you're okay as long as you have on about 35 pounds of N at planting, and then maybe you don't need an extra 20 pounds at side dress, because the extra 20 pounds here probably didn't pay for itself with 5 more bushels of yield. 20 extra pounds of nitrogen and 5 extra bushels of yield probably didn't pay for itself. What's great is these are really good corn yields, and these all followed rye that was of decent size. Okay, then on the corn following soybean system, where the total system had 30 pounds less nitrogen compared to the corn following corn, because he was taking a soybean nitrogen credit. In the early terminated rye, they were both statistically higher whether he put on a lower rate of nitrogen or a higher rate of nitrogen, and these were a difference of 20 pounds, remember, versus the late terminated rye, and their difference in nitrogen again was 20 pounds amongst each other. In this system, the cereal rye in the late terminated was closer to 3,500 pounds of biomass. So it was 1,000 pounds or so bigger than in this system. And so we're thinking that biomass production in the spring matters, and that should influence when we kill cover crop and what our nitrogen program is going to be. I'd say we don't really know if the sweet spot is 2,000 pounds and less, which 2,000 pounds is about knee height. This is about 2,000 pounds of biomass. Is this the sweet spot where we're okay with, you know, our normal program with 35 pounds on at planting, killing it the day before we plant corn? And at this point we're not okay, or is it, you know, mid-calf to knee height? So I think we still need to hone in on where that height is, but it seems like that's really the big difference here, is the amount of cover crop biomass. And that's why we see in the late terminated here statistically lower corn yields. Okay, so a complicated study a year ago led to 2 more very complicated studies this year. Okay, so just to wrap it up, if you're really excited about cover crops and you want to maybe grow your own seed, you could add a cereal rye cover crop seed production to your farm and move into diverse rotation. And so Dick, again, this is Dick, he loves to play around with these trials. He planted corn into either a dead red clover that he'd overseeded with rye the year before, or a summer cover crop mix. That's what was in these strips here, was a summer winter kill cover crop mix. And then he wanted to see what his corn would do in these systems. And so from his corn yield, so he followed either this cover crop mix or red clover, and then planted corn into it, he was able to yield statistically more corn following red clover than following the cover crop mix. And he used the standard program where he has 35 pounds of nitrogen on it planting, and then he follows up with a side dress of 100. So I've had a number of farmers say, you know, that this $30 to $35 investment of cover crops, as they're learning how to find the cash in it, is more than adequate to protect a $5,000 to $10,000 asset. So that's a really great statement. And I think as we figure out the ways to find the cash in cover crops, we can just cover that cost within the cash that we find through cost savings, through increasing yield, through reducing costs, things like that. And that'll help us turn this, which is really unacceptable, right, into something like this. So what questions do you have for me?
What's the average size of your farmers, acre-wise?
Oh, I don't know. We have some that are 4,000 and some that are, well, okay, so we have horticulture farmers and livestock farmers and field crop farmers. And of our field crop farmers, average size is 358. And I have a range of, you know, 10,000 acre farmers all the way down to a couple hundred acre farmers.
10,000 acres cover crop?
No, that farmer does 7,000 acres of the 10,000. I was just at a field day on Monday, and that farmer is a 6,000 acre farmer, and he's gotten 2,700 done already this fall, and they're gonna shoot for 3,000, but they're probably not gonna get over that. That's probably where they'll stop.
Oh, I can't believe there's no questions.
So, Sarah, you talked about mixtures getting better.
So we've tried to overseed cover crop mixtures at the V3 to V6 stage of corn to see what'll survive. And cowpeas have survived okay, but most cover crops don't survive the July window then when corn is too tall. So again, that makes me just reinforces that mixtures really should only be planted in the month of August after small grain harvest or sweet corn or something early so that they have enough time to grow and enough heat units to take advantage of to get really big. And that's where we see mixtures really do the best.
So all the attempts at interseeding with special equipment and stuff, you're just not seeing consistent performance?
So if a farmer's planting population is under 25,000 and if row spacing is like 36 inches or more, then mixtures at V3 will work. But if we're at 36,000, 30 to 36,000 population and 30-inch row spacing, there's just not enough sunlight into the canopy with the species that we've tested so far. So cowpea seems promising, and cowpeas are just soybeans basically. Seems promising. And Lauren Steinlage over in Northeast Iowa somehow gets stuff to work regularly. But other farmers that have tried these systems, we just have failures every year. Even the stuff that you sent down to Jeremy for us to overseed, we tried some of your guys' mixes and we tried some other mixes and just failed.
And that's specifically in corn, any success in soybeans?
We have not overseeded into soybeans. In the window before it canopies, we've overseeded into soybeans obviously in September window, you know, when canopy's opening up, and that's fine. I think we would run the risk of soybeans that didn't canopy, and we would have overseeded into them, and then we'll have a nightmare to harvest those soybeans. Has anybody overseeded into soybeans pre-canopy closure with success?
It's usually late. It's usually like pre-harvest.
Yeah, that works. Yeah, absolutely. The September window and on, that's fine. But overseeding into soybeans pre-canopy closure, that's dangerous. I would not recommend that. Yeah, Elia. So the question was, do we need to get the large radish growth to get benefit to the soil microbes or whatever compared to the small radish? So no, I don't necessarily think we need the large radish for benefit. I think we just were sold that the large radish is the way to go, and then we tried it and we got really small radishes. So we see farmers who have messed around with the small radishes, then going to corn, and seeing a little bit of a yield bump on corn where they had radish mixed with like oats, for example, and they had a radish that was that size. And I could understand why that might happen because radish cycles a lot of nitrogen, it makes a lot of phosphorus available, and so that could be like a, you know, like an early application of nitrogen essentially to corn. So I could see how radish could benefit that way. We'll see in our teabag study, we have a few sites that have had cover crop radishes on them. If they break down any faster than the fields that have rye, for example. Yeah, I mean, I guess we don't have good solid data on how the soil biology is changing by cover crop species. So maybe it's doing something, you know, I don't know. Yeah, up here in front. You had a question?
Yeah, I thought that the larger radishes were basically to break up the hard band.
Yes.
Roll the soil 18 inches, 3 foot down.
Yeah, so his comment is just, you know, the radishes have been sold to us or taught to us to help with alleviating compaction, and they'll go down and break up that hard pan. And they are definitely doing that if we can grow them that big. We do see rye and oats actually put on a lot of root growth as well and get through the hard pan as well. And that's just a function of them growing at cold temperatures and, you know, putting down root growth even when it's only 34 degrees air temperature, and then not winter killing. So which one alleviates compaction better, radishes or rye? I'm not really sure. But they both would, because there'd just be a lot of root growth also with the rye. Or a winter small grain, winter wheat, winter triticale.
You don't like clovers?
Oh, I love clover, but in a corn-soybean rotation, there's not enough heat units to grow them. You know, if you want to plant it with oats, I love red clover. So we have done so many evaluations of cover crop mixes going to corn versus red clover. We've had like 6 farmers evaluate this. They want to try these sexy cover crop mixes after oat harvest or rye harvest or whatever small grain. And that's great. And it looks something like this. And then we always test it against red clover. And this is for sure the best. I get way more nitrogen from red clover in a no-till or a tilled system than probably any 12-way species can match. There's just, I mean, the amount of power of growth out of the red clover is amazing. Now, maybe one day crimson clover or balança or something will catch up, but right now it's really winter hardy. I mean, it's really cold tolerant, so it grows at cold temperatures. You can frost seed it really easily. It's growing in August. When I'm trying to maybe get this planted in August and it's dry, red clover will still be there. I had a farmer this summer who was in the drought area of southeast Iowa. He bailed off red clover, you know, in August, was still getting growth. He tried to seed some 12-way mixes after rye. Nothing got going until September. You know, and so this was way ahead. So it's just much more secure. So I love red clover. But we cannot fly it on into soybeans and go to corn and think we're going to get anything out of it. There's not enough heat, you know? Maybe in Georgia. Yeah.
Are you guys looking at the rates that you're seeding it at when you're doing interseeding? Are you following the bag rate? Are you following NRCS's rate? Are you following your own?
Okay, so what seeding rates are we putting things out at, and whose rates are we following? So we need more research on rates, but I'd say we kind of know enough to get started. So one, we have to measure the 1,000 seed weight per pound. Rye harvested in the north has less seeds per pound than rye harvested in the south. Southern ryes that came out of the Noble Foundation have 5,000 more seeds per pound because they're a small seed, because they've been selected for forage, not for grain, than a northern selected rye like from the University of Minnesota or north, because those have been selected for food or for whiskey, and so you want plump seeds for that. So there's less seeds per pound in the northern varieties versus the southern. But when we're buying rye on the market, who knows what it is? It's VNS, right? So we always just tell farmers to put a bushel out if they want cover, and if they're gonna use it for grazing or for cattle, up the rate to probably 1.5 bushels. If you're planting early, you know, we see that we can get away with a lower rate because we're gonna take advantage of tillering from having heat and sunlight, and that rye that's maybe, you know, just a few plants per square foot become very big because it's able to photosynthesize if it's planted early. But rye planted like now, I would be recommending 65 pounds and over because we're planting so late. And so I need all of those plants to grow some. And so I need more seeds out there. Now, am I basing that off of any science? No. That's just like a lot of observation. So radish, for example, is a 16,000 seed per pound plant. And mustard is a 220,000 seeds per pound plant. And so if you just said plant brassicas at 4 pounds to the acre, you're gonna get a lot of mustard and not very much radish. And actually you need you need less of all of it. So that information is good, and Green Cover Seed is a great calculator, so you can, you know, sort of get within a range of how many seeds per pound are these different species. And maybe you guys have that on your website too, I'm not sure, seeds per pound. But it's good to know within the families where they lay out, where they shake out, but you could also just count 100 seeds 10 times and then weigh that, and then that's how you could calculate the seed weight, so you know how many seeds per pound there are. So our recommendations that are on the back of that sheet are from just a lot of observations, and then we work with Iowa NRCS to reevaluate annually what the seeding rate should be, based off of a lot of field crowdsourcing. And I don't know if Minnesota does that. Iowa has been defaulting all their seeding rates to the Midwest Cover Crops calculator. And so PFI and Iowa State and NRCS get together annually and just reevaluate, you know, how far off are we? Basically, how low could the rate be for rye and still get soil erosion control and, you know, nitrogen scavenging. Farmers want to go on lower rates. They want to go down to 30 pounds per acre. And if you're going to plant that at the end of August, you could do that and have good growth. But if you're going to plant it at a normal time, which is probably October 1st, you really need a bushel. You really need enough plants out there taking advantage of photosynthesis and growing. But if you're paying for it out of your own pocket, I mean, you should experiment. I didn't really answer your question.
You could add about people that are planning for cutting rye in a roll down system, roll a Cooper system are planning about 150.
Yeah, so if you're gonna roll it down, I don't know if I have a picture of this, you really want spindly stalks that will like crimp really well. So you want like 3 to 4 bushels, well, 3 bushels per acre, I think is what I hear the going rate is, the going amount is. And you want that because when you go to crimp it end of May, you want the stem to be really weak so that it will crimp really well. So you need a really high rate. You want low tillering potential. And you want kind of spindly, there it is, spindly plants so that it'll really roll and die. This occurs at the end of May or early June in the life cycle of rye. You could crimp wheat, you could crimp triticale, you can crimp anything as long as it's reproductive, well into reproductive stage. And so planting at a really high rate forces the plant, doesn't allow the plant to tiller very much, and so it's spindly, and so it's just easier to snap and break it. So we have some organic farmers that are now experimenting with planting beans into rye, and I have 2 conventional farmers doing this as well. They're planting soybeans at the normal time, May 5th to 10th, into standing rye that's large. And then they're rolling everything without an herbicide application. They're rolling everything end of May. And they're crimp killing the rye, and they are rolling the beans, and the beans are up about this much. And so far, we haven't had major disasters. I'd say we're still trying to figure out how to get a good kill off the rye with the crimper without snapping the bean plant, because these chevron, these things right here, so this is not a land roller, right? A land roller would be smooth. These things could cut the beans. So land rollers are smooth, and those are probably more optimal. So then the rye really has to be into reproductive stage, into reproductive stage, so that just that land roller pushing it over will snap it, and then you wouldn't ruin the beans. And so then we see beans popping up after that happens. That would be a really great way to control potentially herbicide-resistant weeds by not using an herbicide at all in that system. Now palmer and the weeds probably could get through it maybe into August or September. I'm looking at Megan, maybe. But that's a lot of biomass out there. Yeah?
The guys that are interseeding covers into corn earlier in the year, before V5, are they broadcasting? Are they actually growing it in between the rows, and is there a difference?
So definitely, so his question was, if you're interseeding in the V4 to V5 window with cover crops into standing corn, is it broadcasted or shallow incorporated, somehow drilled or something? So there's definitely a difference in getting it going and keeping it going well into July, so broadcast is worse, unless you have a rain right afterwards. If you had a rain right afterwards and you didn't have too much leftover soybean residue on the field, and there's good soil to seed contact, then it would be okay. And when we've done interseeding, we've gotten it to survive until July, and then in the July window it dies. But when we've had too much soybean residue in between the corn row, then we have to do some sort of shallow incorporation to get it into the ground. Because even with rain, it sometimes won't, get rooted because it's sitting on that residue, the seed is. And even if it rains, it just germinates on top of the residue.
We did a fair amount of air plant on B5 with the Henniker 12 row 30. And that was just, I live in South Dakota, just west of Sioux County, Iowa. And we had really good growth. We did a 5-way species of annual ryegrass and radish and turnip and clover. And this one. That, getting that soil to seed contact is so paramount. And we And I think the question would be, how do we financially know if we're getting paid back for our efforts, other than the fact that we are producing biomass, we're creating activity in the ground. And in this case, a lot of these guys are grazing after the corn is come. So I've always had a problem with trying to put numbers to, you're going to invest this much and how much are you going to get out of it. And you alluded to that to a certain degree. You didn't touch a lot on the grazing aspect. But I think we've had some really good luck. And what we found is it gets 5, 6, 7 inches tall and go dormant until August when the leaves start to shrink back, and then you'll start to get that growth back.
Yeah. So the gentleman's comment was just in South Dakota, west of Sioux County, have been interseeding and had success. Getting good soil to seed contact is key, and you've gotten it to survive. Is your planting population below 30,000?
Oh yeah, no, it's at least 30, probably 32.
It's at 32, and is your spacing 30 inches? Oh, well, that's great. Yeah, so I don't know why we can't get this to work in Iowa. I mean, South Dakota State has had a lot of good publications on like consistently making interseeding work. And I'm not sure, even when we are really good about our herbicide program, it's not surviving past July. It dies, yes. Yeah. Okay, well, you've had good luck with it surviving, so ask that gentleman for all the answers on how to do interseeding well. But the point that you really brought up was about like making it pay quickly by adding livestock to the system. And so if we have that interseeded cover crop and then we're going to graze corn stalks in the fall, which would be great, then we could graze that cover crop with it. And so what's the way to assess the economic return of that cover crop to the system? So we've been assigning the cost of hay savings to the cover crop. So we evaluate what the animal's needs are, and then we do a lot of back calculations, and we measure how much cover crop is out there before the cows are released in the fall. We take a square quadrat and dry it down and weigh it. But then we have no way to know on regrowth how much total tonnage happened over the winter, because the cows may or may not graze here, and we only harvested before they were released. And so we have 4 farmers participating in this livestock grazing study that we've had to really learn how to do this well, how to capture the economics of it. So here's the 4 different farmers on the left here, and there are different cities. They're all sort of north, central, west Iowa, like the headwaters of the North Raccoon. These are the total acres of cover crops that they planted. This was in 2016, I believe. This was the tons of dry matter produced by cover crop in the fall when we measured those square foot quadrats. And so then we multiplied the acres by the tonnage per acre, and then total tons of cover crop consumed by the cow. And that was on the back calculation based on what their needs were, animals per acre and the type of animal, whether it was cow, calf, or feeder, or whatever. Cost of dry matter if we purchased it as hay at $80 per ton, which is undervaluing a very high relative feed value cover crop, right? We're just at $80 a ton. But this is all we can kind of get our heads around right now. And so then value of cover crop dry matter per acre in hay terms is this right here. So we're updating this. We've got more data behind it for this 2017 season. And then one of the farmers had 2 pens of animals from his feedlot. 1 pen stayed in the feedlot and consumed just the DMR. And the other group were allowed to graze corn stalks and cover crops. 200 animals were in each group. Were allowed to graze corn stalks with cover crops for about a month. And that group was $11,000 less expensive to finish than this group that stayed in the feedlot. And so that's significant for 2 reasons. One, having cows walk out of a feedlot and graze is like counterintuitive to feedlot thinking. So for that farmer, that was kind of like, whoa, that's really surprising. And then, so 1, it was good to have the cows out and they could do all those corn stalks. And then 2, just his overall feed was a lot different between these 2 groups, even though those cows were walking around grazing corn stalks and cover crop. And his cover crop growth wasn't amazing. I mean, it was like, I don't know, here or so. So $11,000 on 200 animals is kind of a big deal. And so we'll have more data. We're trying to just piece how we talk about this data. Oh, you have one other thing? Or, Yeah.
We're fortunate enough to have a lot of cow-calf operations in southeast South Dakota, northeast Nebraska, where we're still promoting the idea of growing oats and then going back in with grazer. And my question is, you go anywhere from 3 or 4 species up to 8 or 9 species. Is there any truth to the fact that you get better growth per species if there's more competition?
So just the final comment is if we were able to plant early after small grain harvest and we want to graze those areas, whether we put in a 3 species mix versus a 9 species mix, do we get more growth? Because there is some thinking that more plants out there will benefit all plants. And I would say we don't have solid data on that. In perennials, that is true. Perennials grown in a polyculture have more biomass than themselves planted as in a monoculture. But annuals, I'm really not sure if that actually happens. Okay.
Okay, thanks.
Everybody wants to eat lunch. Thanks.